Hi guys, and welcome to the channel. Digital twins, the innovative backbone of the future, delivering virtual representation of real-world products, systems, and cities. In today's video, we'll be showing you what is a digital twin, what can we do with digital twin, and how it works. Without further ado, let's begin. What is a digital twin? A digital twin is a virtual representation of an object or system that spans its life cycle, is updated from real-time data, and uses simulation, machine learning, and reasoning to help decision-making. This just means creating a highly complex virtual model that's the exact counterpart or twin of a physical thing. The thing could be a car, a building, a bridge, or a jet engine. Connected sensors on the physical asset collect data that can be mapped onto the virtual model. Anyone looking at the digital twin can now see crucial information about how the physical thing is doing out there in the real world. And digital twins let us understand the present and predict the future. What this means is that a digital twin is a vital tool to help engineers and operators understand not only how products are performing, but how they will perform in the future. Analysis of the data from the connected sensors, combined with other sources of information, allows making these predictions. With this information, organizations can learn more faster. They can also break down old boundaries surrounding product innovation, complex life cycles, and value creation. Digital twins help manufacturers and engineers accomplish a great deal, like visualizing products in use by real users and in real time, building a digital thread, connecting disparate systems and promoting traceability, refining assumptions with predictive analytics, troubleshooting faraway equipment, managing complexities, and linkage with systems of systems. Let's look at an example of digital twins in action. And since the primary users of digital twins are engineers, let's use their perspective. An engineer's job is to design and test products, whether it's cars, jet engines, tunnels, or household items, with their complete life cycle in view. In other words, they need to ensure that the product they're designing is suitable for the purposes, can cope with wear and tear, and will respond well to the environment in which it will be used. Digital twins give businesses an unprecedented view into how their products perform. A digital twin can help identify potential faults, troubleshoot from afar, and ultimately improve customer satisfaction. It also helps with product differentiation, product quality, and add-on services too. If you can see how customers are using your product after they've bought it, you can gain a wealth of insight. That means you can use the data to, if wanted, safely eliminate unwanted products, functionality, or components, saving time and money. Digital twins are already helping organizations stay ahead of digital disruptions by understanding changing customer preferences, customizations, and experiences. This knowledge means businesses can deliver products more rapidly with higher quality, from the components to the code. Yet the promise of digital twin can still go further. The use of cognitive computing increases the abilities and scientific disciplines in the digital twin. Technologies and techniques such as natural language processing, NLP, machine learning, object visual recognition, acoustic analytics, and signal processing are just a few features augmenting traditional engineering skills. For example, using cognitive to improve testing a digital twin can determine which product tests should be run more frequently. It can also help decide which should be retired. Cognitive digital twins can take us beyond human intuition to design and refine future machines. No more one-size-fits-all model. Instead, machines are individually customized. That's because cognitive digital twin is not just about what we are building. If you're enjoying the video, then hit the like button and smash the subscribe button. So let's look at what we can do with digital twin. The digital twin technology can be used to replicate processes in order to collect data to predict how they will perform. A digital twin is, in essence, a computer program that uses real-world data to create simulations that can predict how a product or process will perform. With the advancement of machine learning and factors such as big data, these virtual models have become a staple in modern engineering to drive innovation and improve performance. In short, creating one can allow the enhancement of strategic technology trends, prevent costly failures in physical objects, and also, by using advanced analytics, monitoring and predictive capabilities, test processes, and services. Digital twin can be broken down into 3 broad types, which show the different times when the process can be used. Digital twin prototype, DTP. This is undertaken before a physical product is created. Digital twin instance, DTI. This is done once a product is manufactured in order to run tests on different usage scenarios. Digital twin aggregate, DTA. This gathers DTI information to determine the capabilities of a product, run prognostics, and test operating parameters. These overarching types can offer a variety of uses, including logistical planning, product development and redesign, quality control management, and system planning. A digital twin can be used to save time and money whenever a product or process needs to be tested, whether in design, implementation, monitoring, or improvement. Digital twin technology is already widely used in manufacturing, but the situation is changing rapidly. With more companies implementing the Internet of Things in their operational processes, we will see more digital twins employed in various sectors very soon. Half the battle for companies is getting to market faster than their competitors. This is often a problem due to long steps and constant changes in production. When a company uses a digital twin to create a product or service, it greatly reduces their time to market. The product lifecycle is carried out in the digital environment, where all improvements can be made much faster and easier. A virtual prototype validates how your physical copy will behave in reality, thus optimizing efficiency and development time. An important advantage of digital twin technology is that it can solve problems well in advance. This feature is called predictive maintenance. Virtual copies perform constant remote control of their physical prototypes, gathering various sources of information through sensors. The analysis of the collected data allows us to predict possible problems, for example, if a spare part is almost worn out and needs to be replaced. So at the end, let's look at how it works. The life of a digital twin begins with experts in applied mathematics or data science researching the physical and operational data of a physical object or system in order to develop a mathematical model that simulates the original. The developers who create digital twins ensure that the virtual computer model can receive feedback from sensors that gather data from the real-world version. This lets the digital version mimic and simulate what is happening with the original version in real time, creating opportunities to gather insights into performance and any potential problems. A digital twin can be as complex or as simple as you require, with differing amounts of data determining how precisely the model simulates the real-world physical version. The twin can be used with a prototype to offer feedback on the product as it is developed, or can even act as a prototype in its own right to model what could occur with a physical version when built. Digital twins can be created for a wide range of applications, for example, to test a prototype or design, assess how a product or process will work under different conditions, and determine and monitor life cycles. This can include an interface between the digital model and an actual physical object to send and receive feedback and data in real time. Think of a digital twin as a bridge between the physical and digital worlds. First, smart components that use sensors to collect real-time data on status, working conditions, and positions are integrated into a physical item. These components are connected to a cloud-based system that receives and processes all the data that the sensors monitor. This entry is analyzed against business and other contextual data. Lessons are learned and opportunities are discovered within the virtual environment that can be applied to the physical world, ultimately to transform your business. So guys, let me know down in the comments section below, what are your thoughts about digital twins? For more interesting content, give this video a thumbs up and don't forget to subscribe to the channel for more awesome content. Have a nice day, and I'll see you on the next video.